Let's take a look at these same concepts graphically. So this first problem asks you to evaluate f plus g at 1. So really what I'm doing is finding the output at f of 1 and the output of g at 1. So I'm looking at 1 for the input value. The f value at 1 is 1, and the g value at 1 is 4. So when you add 1 plus 4, you get 5. So f plus g at 1 is 5. So if I was going to draw on the new function at 1, I would go up here to 5 and I would put a point. It's not asking us to graph it, but it very well could. Okay, let's do g minus f at 0. So this tells me where I'm going to go for my domain. This is the input value. So this time the input value is 0. So that's along the y-axis here. The g value is 4. And I'm going to subtract the f value, which is negative 2. So 4 subtract negative 2 is positive 6. Okay, let's multiply the f value and the g value at 6. So this time the input, or the x value, is 6. The f value is up here at 3. The g value at 6 is negative 1. And 3 times negative 1 is negative 3. Okay, f times g at 8. So let's go over here to 8. 8, the f value is this one, which is negative 3. The g value is 1. So our answer is also negative 3. Okay, let's think about divide. So this time the input value is 4. So when I go to 4, I'm going to do the f function, which is 3, divided by the g function, which is 1, and 3 divided by 1 is 3. Okay, let's switch that up now, and let's do g divided by f at 1. So this time the g function at 1 is 4. The f function at 1 is 1, so the answer is 4. What about f divided by g at 5? So we're going to 5 here. The f function at 5 is 5. The g function at 5 is 0. And 5 divided by 0 is undefined. So there wouldn't, if I was graphing out this new function, there wouldn't even be a spot at 5 because it's undefined at that spot. Let's think one last time here about domain restrictions. What if I had f divided by g of x? So I would have the f function, which is 2x plus 1, divided by the g function, which is x plus 3. The domain restrictions, if I just look at this one's linear and that one's linear. So they would start as negative infinity to infinity. But now looking at the problem, my new function, there would be a restriction. What number would we not want to put in for x on this particular function? What number, if I put it in for this value, would make this bottom part 0? The value that would make the bottom part 0 is negative 3. So I would never want x to be negative 3. So I would have to write my restriction like this. Negative infinity to negative 3. Skip over the number negative 3 and go to infinity. I know at OTC, when you do this in your college algebra class, they let you write negative infinity to infinity, where they say all real numbers except x can't be negative 3. So you can write it like that, or you can write it in interval notation. I'm trying to prepare you for both ways. OTC lets you write it like this, but in calculus and in IB math, you'll write it like this.